Hello student, welcome to AriserTalent. I am your maths teacher Arpita Sharma. Okay, so what we have studied in our previous session? We have done some examples and theorems on Euclid's division lemma and we have talked about HCF and LCM. So today's first topic is factor tree. We have studied it earlier. Okay, if you have to make factor tree of 32760, how will you make it? Simple process. You will write the given digit first, like this, 32760, and you will factorize it with the smallest number possible. Here the smallest number is that can be factorized 2, right? So this will be 1 6 3 8 0. We will write it here, 1 6 3 8 0, and there will be 2. Now again factorizing this 16380, what we will get? Smallest number possible, 2, and this will become what? 8 1 8 and 0. Now again we'll repeat the process again by 2, and here we will get what? 4090. Again by 2, what we will get? 2045. Now it cannot be divided by 2, so by 9, no, by 3, no, by 5, yes. Four times 0, 9 times. Now 409. So we will factorize 32760 and we'll get the factor tree of this particular digit. We'll write it first, 32760, right? Now we'll factorize it, we'll divide it by 2. It may be divided by 2. 2 is the least possible number. So the first number we'll get here as its factorization, as its factor is 2, and divided by 2, 1 6 3 times, 1 8 times, then 0. Do it with me, do it with me. Again this can be divided by 2, okay, 2, and here 8 1 9 and 0, again by 2. Okay, here we will get 2, and here what will get? 4 0 9 5. Now this digit, is it divisible by 3, 9, 10, 11, 12, 13, 14, 18, right? So divisible by 3. Here we will get 3, and here 1 time, 3 times, 6 times, 5 times. Now again 6, 9, 10, 15, again divided by 3. So here we will get 3 and here what we will get? 4, 5, 5, 455. Now we'll factorize it again. Now 9 plus 5, 14. So not divisible by 3. Now it will be divisible by 5. 5. Here we'll get what? 9 and 1. Now 91 and 5 we got in last. Now 9. It is divisible by not 2, not 3, then 5, not 5, then the next prime number is 7. It is divisible by 7. Yes, it is. Okay. By 7, 7 in the 7. So 1, then 2, 13. Now 13 is again a prime number. Its other factorizations are not possible. So the process stops here. Okay. So how will write the factorization from this factor tree? We'll write from this order, from the smallest digit. Okay. This is 2, multiply by 2, multiply by 2, multiply by 3, multiply by 3, and I have written these two boxes 2 times. So I am considering only one box. Mark this. 5 multiply by 7 and then 13. So this is the factorization of 32760 which was given to us. Now how can we rewrite it? 2 raised to power what? 1, 2, 3. Okay. Then 3 raised to power what? Nothing, because it's simple. It's single here. Now 5, then 7, then 13. Now my point is that you will be writing this in this order, like the smallest one will be coming first, then the largest from this number, and the process repeats. Okay. Now this is the unique factorization of this number, unique prime factorization. You can't have any other factorization of this particular number and having other prime numbers in it. Okay. The only difference may be that you can write it like this, like 13 here, then 3 here, then 5 somewhere else, then 2 raised to power 3 somewhere else. Okay, so we have covered all the numbers. 3, 5, 7. Okay, we have left 7. So order can be manipulated, but not any other factorization is possible, right? Note this. So, factorization of composite number. So, let me first explain you what is composite number. We have understood very well that what is prime number, that can be either multiple of 1 or multiple of itself. Let's suppose x is any prime number we are having. Now, let it be a. Okay. So, if a is a prime number, its factorization will be only 1 multiplied by a. Nothing else can be happen. Okay. So what is composite number? Composite number is basically a number whose factorizations are prime numbers. Now, factorization of composite number. What it says, if x equals to p1, p2, p3, p4, if x. Now what is factorization of composite number? Let x be a composite number. So p1, p2, p3, p4 and pn are here prime numbers. So we can write any composite number in the form of p1 multiplied by p2 multiplied by p3, p4 and so on up to Pn, right? Here P1, P2, P3 and Pn are prime numbers such that P1 will be either less than or equals to P2. Likewise, in previous session, we were having factors like this. So, if we expand this, what we will get? Now, understand this. This is P1, this is P2, this is P3, this is P4, this is P5 and this is P6. So, P1 and P2 are equal. So, either equal or if we come here, then P3 is smaller than P4. So, we will write these factors in ascending orders, not in descending orders or random order, right? So, I think you have understood the factorization of composite number. Why we are studying this? Because we will use this particular expression in solving other things. Property of HCM, HCF and LCF. Property of HCF and LCM. Now, what is the property of HCF and LCM? We have studied both. We have studied both the HCF and LCM. Now, we are discussing the property of it. HCF and LCM. Let us suppose we are having two numbers A and B, two positive integers, right? Now, HCF of A and B, we find that. Now, what we have done? We have also find out the LCM of these two numbers. Now, this property says if we multiply this HCF of these two numbers and LCM of these two numbers, then the result will be equal to the multiplication of A and B. So, the numbers we have taken for HCF and LCM, their multiplication will be equals to the multiplication of their HCF and LCM, right? So, we can write it in this form: HCF A, B multiplied by LCM A, B will be equals to A multiplied by B, where A and B are what? Any positive integers. In our exercise 2.1, we are having questions that are asking for finding either HCF or LCM or both HCF and LCM, and in some methods we have to find HCF or LCM when HCF is given and the two numbers are given. So, what we have to do in that case when HCF is given and LCM is to be find out, or LCM is given and HCF is to be find out and both the numbers are given, we'll apply this formula to find out, right? Remember this. Understood this one? Okay, we'll move forward. Now this question, find the HCF of 96 and 404 by the prime factorization method. It have specified prime factorization method. So you won't do this like if you are given number like 100. So you won't be doing it like this, like 4 multiplied by 25. No, you have to do it in prime factorization method that I have specified you. So, HCF of 96 and 404 by prime factorization method. Okay, we'll solve it here. Now 96 and 404, these are the given quantities, these are the given numbers. Okay, we can find prime factorization by this technique as we are doing from our childhood, right? So 2 times, what we'll write here? The least prime factor possible. So it is divisible by 2. So I am writing 2 here, right? Then by 2 again, 1, 0, 1, right? Then is it divisible by 2? No. 3, no. 5, no. 7, no. 11, no. 13, no. Actually 101 is itself a prime number. So what we will get? 101 here and 1 here. Now coming to 96 by 2. So we'll get 4 here and then 8 here. Do it with me. With 2, 2, then here 4, then by 2 it will be 12, then again by 2 it will be what? 6. Do fast. By 2, 3, by 3, 1. So what are the prime factors of 96 and what are the prime factors of 404 we are getting from here? Prime factors of 96 will be equals to 2. 1, 2, 3, 4, 5. We are having 5 2's. So 2 raised to power 5 multiply by 3. Now 40, prime factorization of 404. That will be 2 raised to power what? 2 multiply by what? 101. Okay. So we will get the prime factorization of 96 and 404. So we have to find the LCM. And there is a small difference between HCF and LCM when it comes to this factorization number. We will snatch out the least power digits, least power common digits in HCF. But in LCM, we are going to do what? Snatching out the highest power from here. Right? So, if we have to find the LCM, we'll having 2 here and also 2 here. And which power is largest? 2 or 5? 5? 5. So we will write it 5 here. Now 3. We are not having 3 here. So we will use this. Multiply by 3. Okay. 3 covered. Now 101. We will having 101 here. All covered. Now this is the LCM. Now we will simplify it. That will be 3, 0, 3. Now 2 multiply 2 multiply 2 multiply 2, 1, 2, 3, 4 and 5. 32. Now calculate this. 6, 0, 6, 9, 0, 9. So what will it become? 9696. So 9696 will be your answer of this question, which was find the HCF of 96405 by. Okay, we have done this LCM. Okay, we have find out the LCM. Now if we have to find out, these steps are for finding LCM, but we have to find HCF. Okay, HCF. Now this is 2 raised to power 5 and this is 2 raised to power 2. So what will be the least common? 2 raised to power 2, right? So it will be 2 raised to power 2. Now see whether we are having 3 common here. No common 3. Okay, 101. No common 10. So 101. So the HCF of these two numbers will be simply 4. Okay, in this particular question I have solved both LCM and HCF for you But remember, the question only asked about HCF. So you have to calculate only HCF. If you have asked for HCF, you have to calculate only HCF, not LCM, right? Okay, I'm rubbing it now. Now we'll do some more exercise, right? Next question is, find the HCF and LCM of following integers by applying the prime factorization method. Okay. I have told you the property of HCF and LCM, right? And in that particular property, I have told you I am having integers A and B, and I told you that HCF of AB multiplied by LCM of AB will be what? A multiplied by B. But I haven't told you that HCF of A, B, C multiplied by LCM of A, B, C will be equals to A multiplied by B multiplied by C. This is not true. So never apply this property when you have given 3 digits. You have given 3 numbers. Apply this property only in 2 numbers. Remember this. Otherwise, you may done your question wrong. So this is the exercise. This is the question. This is the question 3 of your exercise 1.2. Okay. Find the HCF and LCM of the following integers by applying the prime factorization method, and the numbers are given 12, 15 and 21. Okay. So solution is here. Given numbers. When you are giving board exams, you have to write each and every steps in form of language also, right? You have to first tell that what is given, okay, then putting some formula, then explaining some formula if there is a need. If you are using any formula, then you then show it here and then calculate. It's not like you are just rushing to calculate it. No, you have to put it in an order. So given number 12, 15, 21. Now, first step हमारी क्या? Now, what will be our first step? Prime factorization. Prime factorization of what? 12 equals to 2 into 2 into 3. Now we can check it by 2 into 2 is 4 and 4 into 3 is 12. So these are the prime factorization of 12. Now prime factorization of 15. So that will be 3 into 5. Now 5 3s are 15. No more factorization possible in this way. Now the third one, 21. So prime factorization of 21. Now prime factorization of 21 is nothing but 3 multiplied by 7. 3 is prime, 7 is prime. No more prime factorization can possible here. Okay. Now question HCF and LCM. First we will find HCF. HCF of what? Write in bracket 12, 15 and 21 will be equals to least common. 2 is common here. No, 2 is not common here. Then 3 is common here. Yes, 3 is common in all the three numbers given. Okay, so 3 multiply by 5. Okay, 5 is not given here and here, and 7 is not present here and here. So 3. HCF of these 3 digits will be what? 3. Solved for first part. Second, LCM. LCM, L, largest, okay. Then 2 raised to power 2. We can write it 2 raised to power 2 multiplied by 3. Okay. 2 times, any 2 here? No. Any 2 here? No. So, LCM 12, 15, 21. First term will be 2 raised to power 2 because highest power is in this form. Then 3. 1 3 is here, 1 3 is here, and 1 3 is here. So, only 1 3. Okay. Then 5 is here. Then 7. Okay. Now we will solve it. 4, 15, 7, 28, 15. Now calculate 28 and 15. Now calculate 28 and 15. 40, 14, 8, 2. So we'll get 420, right? So LCM is what? 420. You have to write it in another questions on your own, but in this particular question I am writing it in a language form. Okay. So what you have to write? So the LCM 12, 15, 21 is 420 and HCF 12, 15, 21 is 3. Okay, and this will be your answer. So my point is here is this, not you have to only know how to solve this question, but you have to also know that how to present this question in board exam solution, right? Note this. Okay, I am rubbing this now. Now we'll do the next question. Is what? Given that HCF 306 306 and 657 equals to 9, find LCM of 306 and 657. First, both digits are same, and this is A, and this is B, and this is again A, and this is again B. Now, we have studied the formula of HCF and LCM, and I have told you we'll use this formula in question. Okay, so here's the question. We have given HCF. Okay, we have to find LCM, and we have given 2 digits. So how will we solve it? Right, we will use the formula. Solution. First, given that HCF, solve it with proper steps and before me. 306 and 675 equals to 9. To find LCM 306. Okay, now as per the formula, That particular property we will write here. HCF A B multiplied by LCM A B will be equals to what? A multiply by B. Here A equals to 306 given and B equals to 657 given. Putting values in equation 1, we'll get what? Implies that the value is here 9 multiply LCM of what? 306 and 657 will be equals to 306 and 657. Now LCM 306 657 will be equals to what? 306 multiplied by 657 divided by this 9. Okay, we transpose it there. Now by 3, how many times? 1, 0, 2 again. Okay, 1 time, 2, 1, 9. So we got 102 and 219. Now multiplying it, 102 and 219, what will get? 219 and 102, will multiply it, 18, 3, 4, 9, 1, 2, will get 3, 2, 2. So what will get? 2, 2, 3, 3, 8, right? So LCM of 306 and 657 will be equals to nothing but 2, 2, 3, 3, 8. This is our answer. Okay, note this. Okay, note it. I am rubbing it. So we have done questions on HCF, LCM, property of HCF, LCM. Okay, I hope you understood it well. Right, students? Now, this is the question. Note this. We will discuss this question in our next session. Thank you.